What I'm going to try and do over the next 12 minutes or so is give you some idea of how California's transition to the next generation science standards is changing what's happening for science education, for science in the classroom. And I really want to look at this from two perspectives. First of all, my perspective, the teacher's perspective. I started teaching in California in 2001. Actually, it was September the 11th, 2001, but that's a different story. Not too far away from here, in Cyprus at Lexington Junior High School. Then in 2015, after 14 years in junior high school, I finally graduated. I went down the road to Cyprus High School, where I've been teaching ever since. So I'm experiencing the transition to the next generation science standards in the classroom firsthand, so I can tell you a little bit about what the instructional shift looks like and how it's impacting our students. But the second perspective that I really want to look at, and I think is the more important perspective, is of my students, our students. What does the NGSS mean for these guys? How does it affect what we're doing in the classroom, what they're doing in the classroom? And how is it going to affect what they're learning and what they'll take away with them when they leave school? And they may become tomorrow's Dr. Lovelesses. Maybe they'll become a lawyer, businesswoman, maybe even tomorrow's president. So what I want to start by doing is looking at what the NGSS is and how it differs from, this is actually, is this the right one for the laser pointer? No. Red button. Guess who's red, green, colorblind? But that's a genetics lesson right there. Okay, there we go. This is the California Science Content Standards. This is the predecessor to the NGSS. These were adopted back in 1998, and they definitely focused on knowing science. This is some of the 7th grade standards from the California Science Content Standards. Don't worry about the details, but look at how every standard started. Students know, students know, students know. So this set of standards saw science as a body of knowledge, and the teacher's job was to make sure that the students knew about the science. The NGSS, the Next Generation Science Standards, takes a different approach. It is three-dimensional. It combines, there's that button again, scientific practices, cross-cutting concepts, and disciplinary core ideas. The first dimension, scientific practices, recognizes the fact that scientists don't just know science, they do science. And the NGSS makes sure that students are going to do science as well, whether they are asking questions, modeling, carrying out investigations, interpreting data, and so on. Hands-on science is at the core of the NGSS. The second dimension is about cross-cutting concepts. And that tries to make sure that students see the connections between the sciences. So, for example, students will understand that there's a similarity in the way energy and matter flow, whether they're looking at electricity flowing through a wire, solar radiation heating the oceans, or the food that powers their own bodies. And then the third dimension, the disciplinary core ideas, tries to take 13 fundamental ideas in science that are fundamental, that students can learn, that we can teach, and are somehow connected to their own lives or some kind of societal concern. The beauty of the NGSS is the way every performance expectation combines these three things together so that students learn science by doing science. So here's middle school life science performance expectation 1-1. Look what the students are doing. They are conducting an investigation to provide evidence that living things are made of cells. Standard 2-1 has them analyzing and interpreting data to provide evidence of the effects of resource availability on organisms and populations. So just knowing about science is no longer enough. The NGSS explicitly makes sure they can communicate, experiment, question, model, and so on, just like real scientists do. And I think this is really important for what it does to our students. Well, first of all, just learning about science is nowhere near as engaging as actually doing science. Science shouldn't be a spectator sport. And by having our students doing science, they want to keep doing science. Second of all, it doesn't matter how hard we try to pour scientific facts into our students' minds. A lot of those facts, they're just going to trickle away. I know this firsthand. When I moved from Lexington to Cyprus, from the junior high school to the high school, a lot of the students that I saw for the first 2 years in my 9th grade biology class were students I had back in 7th grade biology. So back in 7th grade, we learned about photosynthesis, and my students became very familiar with the details and how to balance the formula for photosynthesis. Then they come back 2 years later, and somehow some of those details seem to have just faded away. They still remember what photosynthesis is about, but the details are gone. So some people might think, well, that's very upsetting to me as the teacher. Not at all. Because now, more than ever, facts are cheap. If they need to know the details of this equation, they can find it in 20 seconds or less. Because they hold in their back pockets more scientific fact than I could ever teach them, and more than I will ever know. So what I care about is not that they remember every detailed fact, but they know how to be a scientist, how to do science. That's the important part, and that's exactly what the NGSS is aiming for. So what does it look like in the classroom? Well, here's one approach that I've been using, project-based learning, or I might call it PBL, because everything in education has to have an acronym. I learned about project-based learning from the Buck Institute for Education, and in a nutshell, it has students gain knowledge and skills by working for an extended period of time to investigate and respond to an authentic, engaging, and complex problem or challenge. What does that mean? Well, let's look at an example. So let's use biogeochemical cycles as an example. The traditional approach would be this. The teacher would get up there and show them, this is the nitrogen cycle, here's the carbon cycle, the phosphorus cycle, the water cycle, and so on, making sure that at every stage, here's condensation, let's make sure we know what percolation is, and so on. The NGSS approach is different. I was working with a couple of colleagues of mine, let's get their names right, Lindsay Kuka and Aaron Doherty, working on a project-based learning module that looks at the same content by giving students the following challenge. Imagine we knew that a meteor was about to destroy the Earth. Can you design a self-contained orb that could be sent into space to maintain a sample of living things indefinitely? And what would you need to place in such an orb if it's going to be successful? So this has students working together, talking about nutrient cycling and energy flow. This is not the kind of project you can give them as like one night's homework. Go home, get the right answer, and come back. They'll be working on this for several days, working together, talking about it, coming up with their model, and then constantly trying to improve their model and perfect it. As I ask them questions like, well, what's going to happen to your organisms when they die? Oh. Or I'll give them little mini lectures. I'll show them little video clips. I'll have them do readings, as they're always trying to make their model better. Here's an example. I'll have them read about ecospheres. These are actually commercially available. You can buy them. They're a little glass orb, which does cycle, have nutrient cycling. It can happen for up to 10 years. It's got, I think, shrimp in there, some algae, and some bacteria, and they can keep cycling. So the students will read about this and then use that to try to make their model better. So when the project's finished, my students understand nutrient cycling and energy flow, not because I've told them about it, but because they've needed to use that knowledge and apply that knowledge to solve a problem just like real scientists do. As a second example, I want to look at a hands-on experiment. If you look in lab manuals, you'll find lots of experiments like this one, asking, how does heart rate change with exercise? I remember doing an experiment like this when I was in high school. Students, they go through the procedure step by step, doing exactly what they're told. They record their data in the data table, and then at the end come to the rather unsurprising conclusion that yes, their heart rate increases when they exercise. So an NGSS approach to this, what I do in my classroom, is to not give them this sort of cookbook type lab, but instead challenge them in the following way. I'll give them the pulse monitors, show them how they work, and then say, okay, your job is to now design an experiment to test the hypothesis that blank affects heart rate. They fill in the blank. So they have to decide what they're going to test. They have to decide how they're going to test it, design the experiment, collect the data, analyze the data, and so on. They design everything. I've had students look at the effect on heart rate of a bunch of things like body position, music, lying to each other, stress, all sorts of things, you name it. And even students that do end up testing whether or not exercise affects heart rate, they have to design their own experiment. It does mean that sometimes they will design an experiment that is flawed. It does not correctly test their hypothesis. But I'd suggest that by designing a flawed experiment, they actually learn more about how to do science and how to correctly design an experiment than running 100 of these sort of cookbook-type labs. So one thing that I do find a little bit more challenging with the NGSS is assessment. And the reason for that is assessing facts, scientific knowledge, is easy. I can give my students a multiple choice test on cell division and see if they know the stages of mitosis. I can scan their answer sheets and get the results back to them in one period. Trying to assess their ability to do science and to analyze their data and interpret science is a lot harder. Oh, I meant to say I do have them write up scientific papers, little mini scientific papers. But as any teacher out there, and maybe some of you future teachers are going to realize, that can become overwhelming. I don't know if this is the same in other districts, but in my district, in the last 16 years I've been teaching, my class sizes have only increased. When I first started teaching, my classes were 30, sometimes even fewer. Now I'm up to 40 or more students. So that every day, these are my 195 students that I see every day. And what that means is if I give them an assignment, which it takes me just 3 minutes to grade, to read it, provide some feedback, and then give them some ways to improve, that's 9 hours plus of work that I have to do after my students have left the classroom. It can get overwhelming. So here's a technique that I learned just a little while ago from Amy Welch over at Brea Olinda High School, which kind of makes that a little bit easier. She calls it a data blitz, and it's pretty simple. Every group that has done a project has to present the results of their group with one slide in 60 seconds. So in that 1 minute, by giving them one slide and 60 seconds, that forces them to really hone in on what's important. It also means that even giving the students a chance to ask each other questions at the end and then give each other some feedback, I can get through an entire class's presentations in one period. At the same time, I can be using this to assess their work, and I can give them some comments so they can improve their experiments the next time. So that's just one way of trying to make assessment a little bit easier with the NGSS. So what I've tried to do in the last few minutes is show you kind of how science is changing under the NGSS. And in a nutshell, it's this. Students are learning science by doing science. If I'm going to give you one piece of advice before I end, to any science teachers out there who are maybe just starting to transition to the NGSS, my advice is this. Don't try to change completely overnight. I totally embrace the changes that the NGSS is giving to us, that I think students should be doing science to learn science. But if you try to throw out everything you've done, it's overwhelming. Instead, evolve slowly. Maybe try one project-based learning activity. Take one lab, try to make it less cookbooky and a little bit more investigatory. I know that I still feel like I have a long way to go before I'm there. But if we keep our students in mind and try to do the best things for them, we will get there and they will be better for it. Thank you for your time.